Hello everyone, this is Noble Mushtak, and today we're going to speedrun the AP Calc AB free response questions from 2019. It is May 16th, 2019, so the people who actually took the AB exam took these questions 2 days ago, but I didn't take the AB exam this year, so I'm seeing these questions for the first time. I have a stopwatch ready. Let me just reset that. I have a stopwatch ready, and then I have my workspace ready where I will be showing all my work. I'll also be commentating on what I'm doing and why I'm doing it so that this video isn't completely boring and will hopefully be of use to people studying for calc exams next year. So yeah, I'm basically ready, so here we go. Fish enter a lake at a rate modeled by the function e of t equals 20 plus 15 sine of... Yeah. Fish leave the lake at a rate modeled by the function L of t is equals 4 plus 2. Yes, okay, cool. Both e of t and L of t are measured in fish per hour, and t is measured in hours since midnight. So first thing, this function looks very complicated. So I'm going to get my graphic calculator out because I don't think I can do any of these integrals by hand, in case I need to do integrals. Um, how many fish enter the lake over the 5 hour period from midnight to 5 a.m.? Give your answer to the nearest whole number. So this is the rate at which fish enter the lake. So integral from 0 to 5 of e of t dt is the integral from 0 to 5 of 20 plus 15 sine of, what is it? Yes, pi t over 6 uh, dt. And I'm just going to do that on my graphing calculator, which I will do off screen, but hopefully you at home can follow with me on your own graphing calculator. So I'm getting 101.7132, which I'm going to round to this whole number, so 102 fishies. Yes, okay, cool. So 1B, what is the average number of lake that leave the lake per hour over the from midnight to 5 a.m.? Okay, so leave the lake is this function, and then average means that we divide the integral by the amount of time, which is in this case 5 hours. So 1B, so I'm going to take 1/5 of the integral from 0 to 5 of L of t dt. Can I type? Probably not. Okay, cool. And that is 4 plus 2 to the 0.1 t squared. What a great function. Yes, okay, copy that down right. So let's take that integral on my graph calculator again. So 1/5 times the integral from 0 to 5 of 4 plus 2 to the 0.1 t squared. Great function. So that it comes out to 6.0590. Do I have to round? They don't tell me to round. So I'm just going to say that's 0.6059 fishes per hour because units. Cool. Okay. At what time t is there the greatest number of fish in the lake? Okay. So how are we given? Oh, so we're not given how many fish are in the lake at midnight, but that's okay. Um, so if we let's say let f of t be the number of fishes in the lake. So clearly f prime, can I? Yes, f prime of t is e of t minus L of t because fish are entering at a rate of e of t and leaving at a rate of L of t. So by the fundamental theorem of calculus, f of t minus f of 0 equals the integral from 0 to t of e of s minus L of s ds, where s is just a dummy variable. So we want to find the maximum of f of t. So one way we can do that is by finding all of the zeros of e of t minus L of t. So in order to make this more demonstrative, I'm going to use a graphic calculator here because otherwise I can't really show you anything. So I'm going to graph f prime of t, which is 20 plus 15. E of t equals 20 plus 15 sine of pi t over 6. And L of t equals, I don't want to graph that, 4 plus 2 to the 0.1 t squared. Cool. I don't want to graph that. I want to graph e of x minus L of x. Okay, so, and I'm only looking on the range from 0 to 8, so I can kind of go from here. And we want to find, it. Well, either the maximum is going to be at t equals 0, it's going to be a t equals 8, or it's going to be where the derivative is 0. And you can kind of see the derivative goes from positive to negative, so we know that this is at least a local maximum because it's going from increasing to decreasing. So one of our the only 0 is 6.204, so we need to check. Actually, this equation doesn't matter. I don't know why I wrote that. So f prime of t equals 0 means that t is 6.204. So if t is 0, oh, I know why. Oops. I do need this equation. Okay, so if t is 0, then obviously, forgot to minus half of 0, very important. F of 0 equals f of 0, because that, hopefully that's obvious, I don't need to explain that. If t is 6.204, then f of 6.204 is f of 0 plus the integral from 6.204 of e of s minus l of s ds. And can I do that here? Hopefully. Yes, I can. Cool. 6.204 of e of s minus l of s ds is 135.0149. So 135.0149 plus f of 0, because I don't really know what f of 0 is. And t equals 8. In that case, we kind of just do the same thing, but we plug in 8 instead. So, and that is, let's just change this to an 8. 80.91 9200. Okay, so 80.9200 plus f of 0. Clearly, uh, and this is probably not the correct way to word this in AP Calc AB answer, but I'm going to do it anyway. Clearly, from the analysis above, uh, f of t is maximized at t equals 6.204. What is the actual? Yeah, so yes, that's it. Hopefully that is correct according to the AP Calc AB rubric. I don't really remember the rubric, but we're going to go with it. Is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? Okay, so as I said before, um, f prime of t, the rate of change of the number of fish in the lake is e of t minus l of t. So f prime of 5, yes, is e of 5 minus l of 5, which is 17.8431. Okay, 17.8431. Fishes per hour. So, and then I can use this f prime of 5 to justify the fact that the rate of change, the rate of change in the number of fish is increasing or decreasing. So I actually want to find, oops, I actually want to find f prime prime of t. I want to find the rate of change that I told you f of t is increasing or decreasing. So that is e prime of t minus l prime of t. And I probably have to show my work to find the derivative. So it is 15/6 cosine of pi t over 6 plus 0.12t, and hopefully you know chain rule, because I'm just gonna kind of keep going here. ln of 2, 2 to the 0.1 t squared. Okay, hopefully that's right. Oh, sorry, this should be a minus sign here. Okay, so yeah, and then I just need to find that for 5. So f prime of 5 equals 15/6 cosine pi 5 over 6 minus 0.1. Oh, sorry. 2 times 5 times ln of 2 times 2 to the 0.1 times 5 squared. Nope. Times 5.1 times 5 squared. So that is negative 0.60861. And to check my answer, I can also just use numerical derivatives. So this will give me the numerical derivative. Ooh, I did something wrong. Hmm. Oh, I forgot to put a pi here. Yeah, so that now, okay, so I should fix that here. So remember to always remember your pi's when you're doing chain rule. So yeah, this is the correct derivative, and then if I plug in 5, I get negative 10 point, yes. I wish I remembered if AP Calc AB allows me to use the numerical derivative or if I actually have to take the derivative, but I already took the derivative, so it's too late. And then our unit is fishes per hour squared. And then I can use this as justification. So f prime prime of 5 is negative. So the rate of change in the number of fish in the lake f prime of t is decreasing at t equals 5, at 5 a.m. Yes. Okay, cool. And then, oh, I'm done. Okay, so 2a. The velocity of a particle p is moving along the x-axis is given by differential function vp, where vp of t is measured in meters per hour and t is measured in hours. Selected values of vp of t are shown in the table above. Particle p is at the origin. Cool. So, okay. Justify why there must be at least one time t between these two, where vp prime of t. Okay, so this is a classic Rolle's theorem problem because vp of t and point t at 2.80 equal, so there has to be some point where the acceleration is 0. So I'm just going to justify that by saying by, excuse me? Okay, so since vp of 0.3 equals vp of 2.8 by Rolle's theorem, and then the other condition is that and vp is a differentiable function by Rolle's theorem, there exists some point, some time t, between 0.3, some time t between on the interval. That's probably more effective. Interval 0.3 2.8, such that v p prime of t equals 0, i.e. the acceleration is 0. So hopefully that's enough justification for Calc AB. Again, I don't remember the specific wording from the class, but that's the basic concept that you need. Okay, almost 12 minutes left. Use trapezoidal sum with the subintervals 0 to 0.3, 0.3 to 1.7, and 1.7 to 2.8 to approximate the value of this integral. Okay, so first I'm just going to write down the area of a trapezoid. So it's 1/2 times height plus the sum of the bases. So here the height would be the width of the interval and the bases are the value of the velocity at those times. So I can split the integral up into our different intervals. So from 0 to 0.3 plus 0.3 to 1.7 plus 1.7 to 2.8. And then I can use the formula to approximate the integrals. So 1/2 times 0.3 times v of 0 plus v of 0.3 plus 1/2 times 1.4 times v of 0.3 plus v of 1.7 plus 1/2 times 1.1 times v of 1.7 plus v of 2.8. And then I'm just going to plug in the values. So 0 plus 55, and then 55 minus 29, and then negative 29 plus 55. And then I think I can type that into here. Hopefully don't make a typo. Yes. Oh. Okay, so that is 40.75 meters. Yes. Okay, so we're done with that part. A second particle q moves along the x-axis so that its velocity is between 0 and 4 given by 45 square roots t cosine. You get the point. You find the interval going towards the velocity of particle q is at least 60 meters per hour. Find the distance traveled by particle q during the interval when the velocity of the particle is at least 60 meters per hour. Okay, so the easiest way to do this is just to graph it. So I should probably erase my things from problem 1. 45 square root x cosine 0.063 x squared. Oh boy. So we should probably zoom in here. Actually, because this doesn't have like a window, the easiest way to figure out when it's over 60 is to subtract by 60 and then figure out when it's positive. So you can kind of see it's positive between these two intervals. So that means the velocity of q is over 60 between 1.866 and 3.519. So I'm not exactly sure how the AP exam wants me to word this, but from a graph of vq of t, and then I'll repeat the function for good measure, cosine of 0.063 t squared, it can be seen that vq of t is greater than 60 for on the time interval 1.866 to 3.519. Okay. And then find the distance traveled by particle q during the interval when the velocity of the particle is at least 60 meters per hour. Okay, so distance is the integral of velocity. So I'll probably say distance equals 1.866, 3.519. Usually you would put absolute value signs, although in this case you don't really need to since it's over 60, so obviously it's positive. So the integral from 1.866 to 3.519 of 45 square root t cosine of 0.063 t squared dt is, if I say this is q of x, and then I can take the numerical derivative again, 1.866. What's the upper? 3.519, and then 1.866 of q of x dx, 106.1092 meters. Nice. Okay. Nope, 2D. I deleted problem 1. 2D. Okay. Time t0 is it's at x equals -90 using the result from port B and VQ. Approximate the distance between particles P and Q at time t equals 2.8. Oh, I see. So, um, particle P is at the origin at time t equals 0. So that means this is the position of V of particle P at 2.8. So let's make that clear. So let P of t be the position of particle P at time t, and for good measure, let Q of t be the position of particle Q at time t. So P of 2.8 is 0 plus the integral from 0 to 2.8 of V P of t dt, and that is 40.75 meters. Q of 2.8 is Q of 0 plus the integral from 0 to 2.8 of V Q of t. So Q of 0 is -90, and then we already know what V Q of t is. Oh, I forgot a dt here. Very important. The t squared dt, and then I can just do that here. So -90 plus the integral from 0 to 2.8, yes, of q of t or x of t dt, 45.9377. I also don't know how many decimal places they want, but okay. And then the distance is the absolute value of their positions, of the difference of their positions. So absolute value of 40.75 minus 45.9377 is, I'm going to use this. So we put that in parentheses. I don't know what that's doing now. Okay. And then what's the other? 40.75 minus that is 5.1877. 5.1877 meters. And I think we are done there. How much time do I have? I have less than, I've done, okay, so it took me less than 20 minutes to do the first section, which usually takes 30 minutes. So I guess that's normal. It's not really that fast, unfortunately. Um, no calculus allowed. Okay, goodbye. Um, I should probably split, just so you know, section 1 took me 20 minutes. The continuous function f is defined at the closed interval that, uh, oh, negative 6 to 5. The figure shown above shows a portion, okay, not the whole thing, consisting of two line segments and a quarter of a circle. Oh, good to know. It is known that 3 minus square root is 5 is on the graph of f. Cool. If that is 7, find negative 6 to negative 2. Okay, so here we are given negative 2 to 5, and here we're given negative 6 and 5. So we want to find negative 6 and negative 2. So the way we do this is by splitting up the integral. So section 2 part B. 3a. Okay, so the integral from negative 6 to negative 2 of f of x dx is that from negative 6 to 5 f of x dx minus that from negative 2 to 5 f of x dx. And actually, I'm going to split it up further. This line goes from negative 2 to 0, so I'm going to say minus negative 2 to 0 f of x dx minus the integral from 0 to 2 minus the integral from 2 to 5. Okay, so what is negative 6 to 5? That's 7. Um, this, I don't know how I'm supposed to justify this, but you kind of see like this triangle is 1/2 and this triangle is negative 1/2. So the integral of that is 0. I'm going to try to justify that somehow. Integral of negative 2, 0 f of x dx is 0 because the area under f of x from negative 2 to negative 1 is 1/2, and the area under f of x from negative 1 to 0 is negative 1/2, so the total integral is 0. Okay, cool. It's from 0 to 2. Um, it's probably easiest if I find. No, I don't want to do that actually. Actually, I do. What's the equation of this line? It goes from 0, negative 1 to um, 2, 3. Okay, so uh, f of x from on the interval 0, 2 goes from negative 1 to 3, so it has a slope of 3 minus negative 1 over 2 minus 0. So that slope is 2, and y-intercept of negative 1. Thus, f of x equals 2x minus 1 for x in 0, 2. Then we can just take the integral of that. That's not how integrals work. Yes, they did. There you go. Okay. Okay, so this is x squared minus 2x, and then yes. So for 2, I get 2 squared minus 2 squared. Did I mess up? Yes, I did. Okay. So this should just be x. I don't know why I said 2x. 2 squared minus 2 minus 0 squared minus 0. So that is 4 minus 2 equals 0. Equals 2. That looks about right. So the integral from 0 to 2 is 2, and then this is a circle. So okay, what's the equation of the circle? Okay, so f of x on the interval to 5 is a circle centered at, what does it say, 5, 3. Nice. With radius, um, obviously radius 3 because this is 5, 0, so radius 3. So x x minus 5 squared plus f of x minus 3 squared equals 3 squared, just from the equation of a circle. And then I'm going to, hopefully College Book doesn't document this. Actually, I should probably show my work. Okay. F of x minus 3 squared equals 9 minus x minus 5 squared. Take the square root. F of x minus 3 equals square root 9 minus x minus 5 squared. Okay, add 3 to both sides. There we go. Okay, so the integral, and I do not have a graphing calculator? Oh wait, I'm supposed to find the area of this circle, aren't I? That would make more sense than finding the equation and taking the integral of the square root. Okay, never mind. So, the area under the curve is the area of a 3 by 3 square, because this is 3 by 3, minus the area of a quarter circle of radius 3. That is a much easier way to solve this integral. So the area of a 3 by 3 squared is 3 squared minus the quarter circle, so that is 1/4 pi 3 squared. So final answer is 9 minus 9/4 pi. Oh wait, that's not a final answer. I still need to do all of this. Okay, so to reiterate, the integral from -6 to -2 of f of x dx is 7 minus 0 minus 2 minus 9 plus 9/4 pi. I'm distributing the negative. So 7 minus 11 is -4, so we get 9/4 pi minus 4. Okay, that is our final answer. That took way too long. How much time do I have left? Oh, that took me 6 minutes. That's a long time. Oh, I have an hour, so I'm good. Evaluate this integral. Okay, this doesn't seem too bad. So first I'm just going to write down the integral. It's the integral from 0 to 5 of 2 f prime of x plus 4 dx. So I want to take the 4 out. So I want to split the integral up, but basically, so 2 f prime of x dx plus 4 dx. So this integral is like 4 times 5 minus 3, so that's 8. And then this integral I can take the 2 out, which will make things easier. So f prime of x dx plus 4 5 minus 3. Okay. Now next step, by the fundamental theorem of calculus, because this is f prime of x, this is f of 5 minus f of 3, so 2 f of 5 minus f of 3 plus 4 times 2. What is f of 5? Oh, so f of 3 is that, because they tell us, and then f of 5 is 0, because the graph, equals 2, 3 minus the square root of 5 minus 0 plus 8 is 6 plus 8 is 14 minus 2 to the square root of 5. Hopefully I can do arithmetic. That looks right. I hope that's not wrong. Okay, 3c. The function g is given by that. Find the absolute maximum value of g. Justify your answer. So a local maximum will appear wherever g prime of x, which is f of x. Okay, so do I have to write that down? Like, it was that obvious. I'm gonna do it anyway. So the derivative of g of x is f of x. So any local maximum occurs when f of x goes from positive to negative. And that really only occurs here. It could have occurred at 5, but 5 is an endpoint, so I'm going to check that anyway. So this only occurs at x equals -1. Therefore, the absolute maximum on the interval -2, 5 is either at x equals -2, x equals 1, or x equals 5. Endpoints are very important. Don't forget the endpoints. Okay, so I guess I just need to allow the integral at all of those points. So the integral from -2 to -2 of f of x dx, which I should clarify, that's g of -2. Hopefully it's obvious that's 0. So g of 1, okay, So g of 1 is the integral from negative 2 to 1 f of x dx. I'm going to split this up into negative 2 to 0 f of x dx, and then 0 to 1. The reason I split that up because I already did this. So the integral from negative 2 to 0 is 0. And then um, I think the function I found was 2x minus 1. Yeah. So that is x squared minus x. I'm going to use this thing from 0 to 1. So that's 1 squared minus, okay, no, minus 1 minus 0 squared minus 0. That's 1, very helpful. The answer is 0, okay. And then g of 5 is not 0, I assume. Oh, didn't I figured this out. So fx dx equals, so I know what, I know that because negative 6 to 5 because they tell me it's 7, and then I know this, negative 2 to negative, no, sorry, negative 6 to negative 2, because I did that before. So this is 7 minus that 9/4 pi minus 4. So that is 11 minus 9/4 pi, which pi is like 3. So 9 times 3/4 is less than 9. So 11 minus something less than 9 is positive. So g of 5 is positive while these are 0. So obviously g of 5 is the biggest. From the above, it can clearly be seen that negative 2 equals g of 1 equals 0, while g of 5 is positive. So the, what is it called? Or what is it? Oh, so the absolute maximum value of g of x is g of 5 equals 9/4 pi. Oh wait, no. 11 minus 9/4 pi. That is not 11. That is, okay, cool. 3D, find something? Oof. Okay. So the limit, I'm just going to copy this because that's a lot to take in. 10 to the x minus 3f prime of x over f of x minus inverse 10 of x. Thanks, College Board. Um, so here you can see that 3 at 1, our slope is 2. So actually, I should probably I'm just going to repeat this for clarity. On the interval 0, 2, f of x equals 2x minus 1. Therefore, f prime of 1 is 2. Does that help us? Yes. Okay. And then f of 1, because the limit, I'm just going to plug in 2 for f prime of x, so in case that wasn't clear. From the graph, f of 1 is 1. So I'm just going to move this limit down here. Periods. Punctuation. Okay, cool. Equals, I think I just plug 1 in. Hopefully, is this really that easy? 10 minus 6 over 1 minus pi over 4, I assume. Arctan of 1. So if you think of a x squared is 2 of triangle, that tan of pi over 4 is 1 in that triangle. So arctan of 1 is pi over 4. So 10 minus 1 is 4. So we get 4 over 1 minus pi over 4. Multiply both denominator and numerator by 4. So we get 16 over 4 minus pi. That was a lot easier than I thought it was going to be. Nice. Hopefully I didn't make a mistake there. Okay, cool. How I have, okay, that was, okay, I have 33 minutes so far. How many problems are there? There's 4 problems in this section. Okay, so I have 3 more left. A cylindrical barrel with diameter 2 feet collects rainwater. The water drains out through a valve. The rate of change of the height is differential equation. Woohoo. Okay, and then volume is, yes, okay. Find the rate of change of the volume of water in the barrel with respect to time when the height is 4 feet. Oh, so this, they give you this formula. So I'm just going to plug 4 into that formula. Wait, am I reading this wrong? Hopefully it's not that easy, is it? Oh, volume. Okay, it's not that easy. Cool. So v of t is pi o squared h. O is constant, so that becomes 4 pi h. So dv over dt. Actually, I'm gonna say v prime of t, it's easier, is 4 pi h prime of t, and then that becomes negative 4 pi over 10 square root h. So v prime of t, where h of t equals 4, is negative 4 pi, negative 4 pi. Oh, sorry, the radius is 1, so this is pi h. That was close. The diameter is 2, the radius is 1. Negative pi over 10 square roots of 4 is negative pi over 5 feet feet cubed per second. Wait, yes. I think I did that right. I just want to read this. Water is draining out, so it's negative. Okay, I think that's right. Cool. When the height of the water is 3 feet, is the rate of change of the height of the water increasing or... Oh, okay, so is dH over dt increasing or decreasing at 3 feet? Okay, so to figure that out, decreasing with respect to time, yes, okay. So the derivative of the derivative is, by power rule, negative 1/20th over square roots of h. So negative 1 over 20 square roots of h. There we go. So if I plug 3 into there, I'm going to say h prime prime of 3, because that's, oh, actually no, h prime prime of t, where h of t equals 3 is negative 1 over 20 square root of 3. So that's negative. So at h equals 3, h prime prime of t is negative. So the rate of change of the height of water with respect to time is decreasing. It seems suspiciously easy. I feel like I'm missing something. I just want to be careful. Tread water carefully. Okay, I don't think I'm missing anything. 4C. At time t equals 0, the water of the height of the water is 5 feet. Use separation of variables. Okay, so this is what we all expecting. Solving differential equations. Okay, so dh over the square root of h is negative dt over 10. If I take the integral of that, of both sides, so I should probably denote that I'm taking the integral. So from it says the height of the water is 5 feet, so I want to take it from 5 to h. dh over the square root of h equals the integral from 0 t of dt over 10. Oh, sorry, negative. And then, so the integral of h to the negative 1/2 is negative 2 square root of h. Yes. And then this obviously just becomes negative t over 10. Except I took the integral from 5 to h, so I should probably denote that. 5 to h. And this integral was from 0 to t. So if I plug in those values, it becomes negative 2 square roots h plus 2 square roots 5 equals negative t over 10. And then if I solve for square root h, then this becomes negative t over 10 minus 2 square roots 5 divided both sides by negative 2. And square root h equals, yes, t over 20 plus square roots 5, and then you square both sides. What an intuitive answer. T over 20 plus square root 5 squared. Great. And then if I take the derivative of that, that's going to become 2t over 20 plus square root 5 times 1 over 20 by chain rule. So that is 1/10 square root of h. So did I miss a negative? Wait. Yes, this negative should not be here. Okay, so this is minus. This becomes plus. This. Oh, but this stays if I divide by 2, then this stays a negative, um, and this stays a negative. So it's a good thing I caught that. So minus t over 20. Hopefully you see this should not be negative. So I don't know why I put a negative sign there, but squared 5 minus t over 20 squared. So if I take the derivative of that, negative 1 over 20 times by chain rule times 2 times squared 5 minus t over 20. So that satisfies the differential equation. So my answer is correct. And then at 0, the water over the height is 5 feet. Good. So for 40 minutes. Let O be the region enclosed by these graphs, and then vertical line x equals 2. So that's right there, and then y-axis. Find the area of R. So 5a, the area of R is the integral from 0 to 2 of, which one's on top? This one. Negative 2 plus 3. Oh, sorry. So negative 2 plus 3 is 1. So this is g of x, because at 0, this will be 1. And then h of x, 6 minus 2 is 4. So that's this one. So h of x is on top. And I'm not allowed to use calculator. Okay. So the integral from 0 to 2 of 6 minus 2 x minus 1 squared minus negative 2, so plus 2 minus 3 cosine pi over 2x dx. So that equals 6x minus 2x minus 1 cubed over 3 plus 2x minus 3, no, minus 6 over pi, because I'm dividing by pi over 2, so 3 over pi over 2 is 6 over pi, sine of pi over 2, no, yes, pi over 2x, from 0 to 2. So, if I plug in 2, then I get 12 minus 2, 2 minus 1, yes, 2/3 plus 4 minus 6 over pi, sine of pi is 0. Okay, and then minus, if I plug in 0, I get 0 minus plus 2/3. Because 0 minus 1 cubed is negative 1, and then negatives cancel, plus 0 minus 6 over pi times sine of 0. So that's also 0. Okay, so in total, I get 12 plus 4 is 16, minus 2/3, minus 2/3, because this minus 2/3 and that minus 2/3. So that the 16 times 3 is 48, 40, so 44/3. That is our final answer. Okay, cool. 5b. Region O is the base of a solid for the solid at each x. The cross section perpendicular. Oh, so this is the area. It doesn't tell you what shape the cross section is, it just tells you the area. That's odd, but okay. So find the volume of a solid. So the volume of a solid is literally just the integral of the area. So from 0 to 2, a of x dx. Dx over x plus 3. The integral of x plus 3 is ln of x plus 3 from 0 to 2. Oh yeah, so ln of 5 minus ln of 3. I don't know which one they would accept as simplified. Ln of 5 minus ln of 3 over ln of 5/3. So I'm just going to write both. To me, this one kind of seems more simplified, but maybe they want the condensed form. I don't know. 5c, write but do not evaluate an integral expression that gives the volume of the solid generated when you rotate it on y equals 6. Y equals 6 is all the way up here. And so just to be clear, the maximum of h of x is at x equals 1 because this is quadratic and this is in vortex form. So everything is under y equals 6. So you don't need to worry about something that's above y equals 6. That makes this problem a bit easier. So because we're integrating over the y-axis and we have two curves, I'm going to use Washer's method. So the integral from 0 to 2 of pi, and then notice that g of x is further away from the y equals 6 line, so pi of 6 minus g of x squared minus the inner washer, which is 6 minus h of x squared dx. And equals, and I'm going to put the pi out front because that's probably easier. 0 to 2 of 6 plus 2 minus 3 cosine of that, whatever that is, pi x over 2 squared minus 6 plus 2 x minus 1 squared dx. So that equals pi times the integral from 0 to 2 of 8 minus 3 cosine, I'm not typing, okay. Integral from 0 to 2 of 8 minus 3 cosine pi x 2 squared minus the 6's cancel, that's nice. So 4x minus 1 to the 4th. Wait, is this a... Okay, I'm gonna square that. This is a no calculator section, right? Okay, that's it. Okay. Equals pi. This looks like BC. Okay, whatever. 64 plus 9 cosine squared pi over 2x minus 24, 48. So the reason I'm saying BC is because cosine squared is an integral I learned from BC, so I'm surprised to see it here, but you know, go with the flow. Pi over 2 x minus, that stays the same. So, in case you haven't learned this before, cosine, nope, cosine of 2 theta is 2 cosine squared theta minus 1, so cosine squared theta is whatever that, how to solve equations. That, okay. So cosine squared of pi over 2x is cosine of pi plus 1 all over 2. So we get equals pi of 0 to 2, 64 stays the same, and then we get 9 halves times cosine of pi x plus 1. I'm going to distribute the 9 halves in one step just to make this faster. Minus 48 cosine of pi over 2x minus 4x minus 1 to the 4th. I really hope I'm not making a arithmetic mistake here. Equals pi times 64 times 64x plus 9 over 2 pi sine of pi x plus 9 halves x minus 48, wait, actually 96 over pi sine of pi over 2x minus 4/5 x minus 1 to the 5th. Isn't that just a great integral? So from 0 to 5. So if I plug in 5, what's 64 times 5? 320. What's sine of 5 pi? 0. So I'm going to ignore that term. What is sine of 5 pi? Oh, of course, 9 halves times 5 is 45 halves. What's 5 pi over 2? That's basically pi over 2, so 1. So minus 96 over pi. Sine of 5 pi over 2 is 1, so that cancels. 5 minus... Why am I doing from 0 to 5? 0 to 2. Okay, that makes things easier. 128 plus sine of 2 pi is 0, 9, because 9 halves times 2 is 9. Sine of pi is 0, so that ignore that term. Minus 4/5 times 1/5 to the 5th. Minus, and if I plug in 0, 64 times 0 is 0. Sine of 0 is 0. 9 halves times 0 is 0. Sine of 0 is 0. So the only term that matters is this one. Minus negative 4/5. So I'm just going to make this positive. 4/5 times negative 1. Okay. Sorry, no, I should not have made that. So minus 4/5 times negative 1, because negative 1 to the 5th is negative. Yeah, so we have 3 negatives here. That's nice. Equals 128 plus 9 is 137. 137 times 5 is 500 plus 150 plus 35 is 185, 685. So 681 pi over 5 minus 4 pi over 5. That gives us 677 pi over 5. I can't believe they put that in a non-calculator section on an AB exam. I'm so sorry for you all. And we have, okay, good time, good time. So I have 40, if this was the actual exam, I would have 40 minutes left, which I think is pretty good. Did I miss something? I hope that's right. I really hope that's right. I'd be very disappointed in myself if that's wrong. Got a bunch of these. Okay, let's go on. Functions f, g, and h of twice differentiable. Ooh, very exciting. With g of 2 equals h of 2 is 4, y is tangent to g and h at x equals 2. So what that tells you, tangent line, that tells you something about g prime of 2 and h prime of 2. So g prime of 2 is 2/3, h prime of 2 is 2/3. Also, g of 2 and h of 2, or whatever, is 4, because if you plug 2 in this function, you get 4. So that's just something to realize. Find h prime of 2. I'll tell you, h prime of 2 is 2/3, because tangent lines. Yeah. So whenever you see tangent line, that's what you should be thinking. What does this tell me about the function, and what does this tell me about the derivative? The derivative is 2/3. So h prime of 2 is 2/3 because the tangent line to h of x at x equals 2/3 has slope of 2/3. Oh, sorry, x equals 2. Okay. Let a be whatever this is. Okay. Um, Find a prime of 2. Okay, so first find a prime of x. So a prime of x is product rule. So 9x squared h of x plus 3x cubed h prime of x. So first I should probably note h of 2 is 4 plus 2/3, 2 minus 2 equals 4 because the tangent line hits h of x at x equals 2. Hopefully that makes sense. Basically, the tangent line has the same value of h of x at x equals 2, because that's how tangent line work. So h of 2 is 4, and h prime of 2 is 2/3. So a prime of 2 is 9x squared times h of 2, which is 4, plus 3x cubed times h prime of x, which is 2/3. So that's 36x squared plus 2x cubed. Oh, x is 2, so 36 times 4. I find equal sign. 36 times 4 plus... That's helpful. Okay, so my internet went out, so I stopped the timer, and then I tried to record again, but my internet was still broken, and the timer kept running for 7 minutes and 12 seconds more. So we're gonna restart the timer and subtract 7 minutes and 12 seconds from our final time, because this, I wasn't actually working on it, I was trying to fix the internet. So, start. Um, oh, I was here. So I was trying to find a prime of 2. And a prime of 2 is 9 times 2 cubed, because x is 2 now, h of 2, but h of 2 is 4. I'll put that in later. 3 times 2 cubed times h prime of 2. So that is 9 times 8 times 4, because h of 2 is 4, plus 3 times 8 times 2/3. I should probably fix that. C dot, not x dot. Okay. And 9 times, oh, sorry, this should be squared. 9 times 4 times 4 is 9 times 16, which is 144. 3 times 2/3 2 times 8 is 16. 144 16 is 160. And that is a prime of 2. 6c. The function h satisfies this fraction for x is not equal to. It is known that the limit for as x approaches 2 of h of x can be evaluated using L'Hopital's rule. So the limit of this fraction can be evaluated using L'Hopital's rule. Use that limit to find f of 2 and f prime of 2. Interesting. So since we know that L'Hopital's rule applies, well, first off, since we know h of x is continuous, we have limit as x approaches 2 of h of x is h of 2, and that is 4, because I said that before. And then we have, actually, I should probably put the fraction in. So limit as x approaches 2 of x squared minus 4, or 1 minus f of x cubed equals 4. Okay, so we want to find f of 2 first. So if L'Hopital's rule applies, that means the numerator is 0, which we can check. 2 squared minus 4 is 0, and the denominator is 0. So if I plug in 2 for this denominator, it should be 0. So, um, since L'Hopital's rule applies, the denominator of this fraction is 0. So 1 minus f of 2 cubed is 0, because when I plug a 2 in, I should get 0 over 0. So if I solve for f of 2, I get f of 2 equals 1. Pretty simple. Then if I actually apply L'Hopital's rule, so take the derivative of the numerator, the limit as x approaches 2. So x squared minus 4 has derivative 2x, and 1 minus f of x cubed has derivative minus 3 f prime of x, because chain rule, times f of 2 cubed. No, f of 2 squared. There we go. Equals 4, because I took the derivative of the numerator and of the denominator. Oh, sorry, f of x squared, because not we. Then we plug in the 2 because I'm assuming that this L'Hopital's rule no longer applies, so I can just plug in 2 now. I'm not going to get a 0 over 0. So when I plug in 2, I get 2 times 2 minus 3f of 2. So sorry, minus 3f prime of 2 times f of 2 squared equals 4. So multiply both sides by the denominator. 4 equals 4 times negative 3 f prime of 2 f of 2 squared. So divide both sides by 4, you get 1 equals negative 3 f prime of 2, and then f of 2 squared. F of 2 is 1, because I found that before, so f of 2 squared can just be ignored, so it's negative 3 f prime of 2 times 1. So we divide by sides by negative 3, and get f prime of 2 is negative 1/3. Okay, yes, and I think that's right. So 60, finally. Yes. So it is known that g of x is less than equal to h of x for 1 is less than x is less than 3. Let k be a function between g and h for 1 to 3. Is k continuous at x equals 2? This is a weird problem because it's squeeze theorem, and you never see squeeze theorem problems. But we're going to do it anyway. Hopefully you know what squeeze theorem is. So, for the two conditions for squeeze theorem, since both g and h are continuous, so since g of x and h of x are continuous, and the limit as x approaches 2 of g of x equals the limit as x approaches 2 of h of x is 4, because remember the tangent line, if you have both g and h have the same tangent line at x equals 2, then both g of x and h of x intersect at the same point at x equals 2, and they intersect at y equals 4. So both of these limits equal 4. By those conditions, squeeze theorem applies. And by squeeze theorem, the limit as x approaches 2 of k of x must equal that of h of x. Or g of x. It doesn't matter which one you choose since the limits are equal. And that equals 4. So that tells us the limit as x approaches 2 of k of x is 4. So it's just one part of figuring out if k is continuous. The other part of figuring out if k is continuous is what is k of 2. So k of 2, it doesn't actually give us a formula for k, but it does give us this inequality, which we use for squeeze theorem. But the other thing we can use it for is for finding k of 2. So if I plug in 2 into the inequality, I get this. So what is g of 2? It's 4, because the tangent line, again. And then what's the h of 2? 4. So k of 2 is between 4 and 4, so k of 2 is 4. So you can see the limit as x approaches 2 of k of x is 4, and k of 2 is 4, so it has to be continuous. So, since the limit as x approaches 2, nope, oh boy, x approaches 2 of k of x equals k of 2. That's the definition of continuity, so k of x is continuous. Can I spell continuous? Yes, I can. Okay, at x equals 2. And we are done. Okay, so I'm ignoring this one because this was me trying to figure stuff out. So we take 19 minutes plus 59 seconds plus 52 plus 6, 8. Actually, this is the sum of all of the times, so I just subtract 7 minutes from that. So let me use a calculator. So 65 plus 31.6 is 0.95 minutes, over 60 minutes. So this is the number of minutes in the calculator, minus this, so minus 7 minus 12.523 over 60. So this is the number of minutes I ran. So 58.3, so 0.3095 times 60. So 58 minutes and 19 seconds, basically. So that's pretty good, 58 minutes, 19 seconds. It's not as fast as I thought it would be. I thought it'd be able to do it in half the time. I did really in 2/3 of the time. 20 minutes for section one for port A, which took 30 minutes, and then 40 minutes for port B, which takes an hour. But it's pretty good, less than an hour, which is nice. So yeah, hopefully I didn't make any mistakes, which would give me a penalty of over an hour. But I probably did. If I go back here, um, yeah, this was a very hard integral problem. I did not expect this to come up at all. I mean, I expected solid revolutions. I didn't expect like to have to do the cosine squared thing because that's something from Calc BC, I think. Squeeze theorem was rather surprising, but it's in Calc AB, so it's not that surprising. I used Rolle's theorem once, which was interesting, but not mean value theorem comes in AB, so that's not too surprising either. But yeah, this was overall pretty hard. Yeah, and to be honest, at least Port B was hard. Port A wasn't too bad because you had a calculator, but Port B, some of these integrals, some of this logic was L'Hopital's this was a weird problem. Using L'Hopital's rule to find f2 and f prime f2, like it's doable. It's not something that most students would think of, I think, but maybe you got it. I don't know. And if you saw any mistakes I got, please comment about that. If you think there's an easier way to do any of these problems, please, if you think there's an easier way to do this problem, I would really appreciate that because that was long. Yeah, and maybe you want to make your own speed run so you can beat me. I would appreciate seeing that. So yeah, just comment below. Tell me about any mistakes I made so that I can figure out what my penalties should be, and I will see you next time.